Sean's taking his AP.
Oh, his AP test. Hi, Sean. Hope you're doing well, even though by the time you get this, it'll be over. Huh?
So we get like test for the test.
Give me a second until we do logistics.
Okay.
No, you can just go back together. All right, guys. Voice is better and audible, but the more I use it, the harder it gets. So. Our goal today for Sean and anyone else who's coming. Is it Sean? Oh. So our AP again, guys, just listen up, and the rest of you guys too. We're going to check our 10-6 homework. Our 10-7 homework and our 10-8 homework, right? For those of you that got on Friday, hopefully you watched the video. Long story short, we caught up. We started catching up. Or we were supposed to over the weekend. They finished catching up. Because tomorrow we're going to have the chapter 10 Big Quest. I'm calling it a quest because it's an important quiz. It's not like 5 points, it's like 25 points. Less than 100 points, but it's on 10-6, 10-7, and 10-8. Last year I think it was a full test. You guys were a little lucky. I'm just making a request. But listen. Still important. Still worth a good amount of points. Wait. It's on 10-6, 10-7, 10-8. You are allowed to have your calculator for most of it. But as I said earlier, we're going to start off with, and Sean and Eris, if you guys wouldn't mind texting them and be like, hey, you have to check out the video because I already kind of delayed the date for this. It was supposed to be today and I'm making it tomorrow. If it was today, they would have had to make it up anyway. So we just want them to hopefully be as on track as possible. We're starting chapter 12 on Wednesday. Okay, so at the very beginning of the test, there is going to be graphing without a calculator. So how do you graph parametric equations without a calculator? Table. There's going to be a t range. -2, less than or equal to t, less than or equal to 3. I think that's what we had in our notes. Set the little table and say t is -2, -1, 0, 1, 2, 3. X, plug it in to the x equation, get all the x's, plug it into the y equation, get all of the y's, and then you graph all of your points and you connect them usually with a curve, showing your little orientation with angle arrows. That's it. That's parametric. Polar. How do you graph by angle? And which angles do you choose? Maybe all of them, and you approximate with decimals, and then we're square root of 3 over 2, and square root of 2 over 2, because you want to have more points to better connect. Or you're like, I've worked hard on getting a general understanding. Whether it's going to be one of those lemniscate ones, or whether it's going to be one of those lemon ones, or one of those like cardioid ones. What else? Or maybe like a rose. I don't think I've made you guys graph one of those countries. Those are kind of tricky. They go like different quantities. Probably more of like the lemon, one of the different types, including maybe the cardioid or the lemniscate. Those are the easy ones to graph. But anyway, you pick and you have to, without a calculator, know your unit circle, right? Take your little points, you plot them on. Do you have to draw all the concentric circles and all that jazz? No. So on that part, that's all you guys graphically did in class. Then transition. Turn that part in. You get your calculator part, calculator out. Make sure you're in par mode or polar mode, depending on what the question is. If I ask you any polar graphing on the calculator part, I'll probably give you the nice little concentric circles for you guys to show me points. You don't have to stress about like getting it all set up and whatnot. But on the beginning graphing part, it's by hand. Everything's by hand. Does that make sense? Okay. And then the calculator part, you can be eliminating a parameter. You could be graphing polar points. That's like the basic of polar. You could be converting equations. So there are some equations that we'll go over, like some important formulas, etc. So we'll talk about that after we check our 10-7, 10-8. Let me get your guys' notes on because that's where the answers are. Out of here. Where's honors? Here we go. I'm in honors. You guys are all in honors. Anyway, let's go back to section 10.7, which was the beginning of polar. Let me pull it up here on the screen. Let me make it big. Let me make it so you can see 4 feet first. geez, speaking of important equations, aren't those kind of most of them? If you have the x equals r cosine theta, y equals r sine theta, y over x is opposite over adjacent is tangent of theta, and r squared equals x squared plus y squared. These are the most important ones besides just doing your triangle. Let me just use this as a teaching opportunity for the formulas that you should know for tomorrow. Not near as many as the conic section you ones, so no, I'm not going to recommend them. Don't ask me tomorrow. Else I might make the bonus regular credit. I'm drawing a triangle, all of these formulas come from. Because all of these formulas come from the relationship between theta and r with x and y. So if you know that triangle, you should be able to get all of the formulas out of it. Because the aggravated theorem tells me x squared plus y squared is r squared. Tangent or trig tell me that tangent of theta is y over x. The other trig functions tell me that sine of theta is opposite over hypotenuse, y over r, and move r to the other side. Cosine tells me cosine of theta is adjacent over hypotenuse, move r to the other side, and you get that one. And if there's anything else funny that comes up, say cosine theta is in an equation, you can say whatever, triangle, adjacent over hypotenuse. The triangle, I would say, is most important, but it is easier if you have an understanding of the basic formulas that we use to convert. Thank you for letting me do that. Sorry it took a little bit of time. I did say that we were going to talk about formulas, and these are pretty much the summary of the most important formulas to know. Kind of the whole thing. Did you guys already get number 8? Did you get graphed okay? Negative 3 pi over 4. Maybe go down to the third quadrant. If it was positive, you would have gone towards that angle, but it was negative, so we went backwards. That's why it's on this line instead. There's other ways of getting there, just pi over 4, go out 1. Or you could have gone 5 pi over 4, gone this way, backward. But technically, there are infinitely many different. Any other ones that you guys want to check, or were those kind of basic? Number 14 and 26, I think. Are those the only others? No, we. 14 and 26, there are some examples. 14, you're doing the same thing, graphing the point. It was at the pole. What does it take for a point to be at the pole? What's important, the radius or the angle? To be at the pole, the radius must be 0, and the angle can be then right? As long as radius is 0, whatever, that's pole. Polar coordinates. You have an r, you have a theta, plug and chug to your formulas, and know your unit circle. Once again, you guys only really need to know the unit circle for graphing the formula by hand, but it'll make it easier for these types of problems. Cool. Alright, let me freeze the screen while you guys check these ones. I'll go find 52. People watching the video, if you just rewind a little bit, you can pause and see what they're seeing. I'm just quickly getting them the solutions that they're looking for. $52, you said? All right, 52. I have 5 and 3.78. Guys, thank you. What else are we looking at? I have 5 and 3.78. Once again, pretty quick, just to plug and jump. 5 and 3.78. And then, is anybody else still checking any of these ones? 72 and 8. Nope. Then going down to number 122. This one was a little bit harder. I actually probably wouldn't have even gone this direction. I might have. Of multiplying both sides by r's, because if you multiply both sides by r's, all of a sudden, like, you have some really nice formulas to plug into. That is one way. The other way is just go back to the triangle and say, okay, whatever. Who's cosine? Well, you figure it out. I have x, I have r, I have y. So instead you could have said, oh, cosine is just x over r, isn't it? So that's the other way of looking at it. Thinking about the triangle, adjacent over hypotenuse, you can multiply r to the other side. Then you can plug in x squared plus y squared. It gets you to the exact same place. But one, you're bound to only using those formulas you're memorized. And the other one, you're like, oh, hey, I have all kinds of options. Who's cosine? Let me find that for you. There he is. So once again, options. You end up at the end of the day trying to, they completed the square to make it all nice and pretty. Because they figured that was easier because now you have a center of 2, 0, and your r is equal to 2. Just a circle, not even an ellipse. But if that confused you, you could have divided everybody by the 4. And even if you thought it was an ellipse, you still should have gotten 2 and 2 in both directions, which is not the definition of a circle. The radii are the same. Alright, kiddos, any quick questions on section 10.7? Alright, moving on, 10.8. Sure, okay. A couple of you not so sure. Alright. Yeah. 10.8. Now guys, these are for the pictures. The pictures were just in the notes. So you could have found them. Remember, I told you which ones I want you to understand, like the names of them. But I told you didn't necessarily have to memorize the equations for them. Whether or not you can use your table to get 1 on that first part of the test plus on the test because we're reviewing it. And then you're going to have your graphing calculator, and if you know how to use your modes, you'll be okay. You can see them. So the limassol, that's enough for number 3. For my purposes, yes, you call it a convex. Number 4 is a circle. 5 is a lemma scale. 6 is a cardioid. Cardioid comes to a point because it comes to the pole. The cardioid, just think about the heart. It has that little cusp, is what we call it. Number 7, it's a rose curve. Don't just call it a flower curve. Specifically, mathematically speaking, you just call them roses. It is what it is. A rose curve with 4 petals. 8 is a cardioid. 9 is a limassol with the loop. Is important as far as the picture. I would just take a limassol. 10 is a lemma scale. 11 is a rose with 3 petals. 12 is a circle. Okay. I only had odds in there because it was easier than just taking pictures of all the people. 14. They had you test for all the symmetries. I would not have you do that tomorrow. Remember what I said is be aware of what they look like. So I would have said number 14, to be honest, even though the directions I'm sure were different. How I modeled it in class, I would have said, hey, let's get the picture of this thing. See that it's a rose that goes, what, out 9, I think? Let's go out to 9. And when you graph or you see the cosine, say like, psh, of course it has a polar axis symmetry. It has cosine, you not have to go through all that stuff. But that's just me. I think that's easier than memorizing all the function notation and stuff. Okay, number 22 and 38. Let me give you guys a second. On the maximum, remember the maximum is always a positive number. Maximum is always a positive number. They went ahead and also figured out what angles the maximum happens. Remember, unless they give you a range of angles, there technically are infinitely many places. You could have just said pi over 4 is at every pi over 4. That's when it's going to occur. But you could have listed them out. They went ahead and said equal to. You guys could have tried to set up an equal and just plug in. Remember when sine is 1 and negative 1. Different things to do in that as well. But the maximum is 3. When sine is equal to positive 1. What's going to happen at every pi over 4 angle? They show some of the math here. They didn't quite show all of the connections. Technically, you would have said when is sine plus or minus 1, which happens at every pi over 2 and pi angle. So 0 pi over 2, pi, 3 pi over 2, 2 pi. And then you would have had to divide them all by 2 like we modeled in class. You would have had to divide them all by 2, which is how you would have gotten all the over 4s. Oh yeah, it only happens at pi over 2. I don't know why I said pi. Sorry, sine is 0. But speaking about the zeros, when is sine 0 at all of the pi over 2s? So technically at 0, at pi up here, 0, pi, 2 pi, 3 pi, 4 pi, we have to divide by 2, which is how we got to the pi over 2s down below. It's by doing that last dividing by 2. So max is 3 at all pi over 4s, and max is, sorry, and the zeros are at all the pi over 2s. 0, 1, 2 pi over 2, and 3 pi over 2. 38 is over here just chilling. If you guys look at your picture, yes, it has pi over 2 symmetry because what's on one side of the pi over 2 is on the other side. We would call it y-axis symmetry if it wasn't polar. Looking at it, yes, we have the limit on with an inner loop. You could have used clues and whatnot, but then remember, if you want that for the test, you have to memorize all that stuff. The maximum is 9. It's the highest it goes when sine is equal to positive 1. That's going to equal 0 at pi over 6s in the third and fourth quadrant. Can't trade 54 and trade down 38. Is anyone still working on 38? I think these are the last two. 54 and 62. I went ahead for sake of illustration, just in case. Just in case you wanted to see the window, there's the window that you would need. Here in radians, pi over 2 is a good range. They put pi over 24. But guys, you could have done like 0.1, 0.2. You don't need to put pi over 24. There's no magic in that necessarily. You could have gotten it to negative 3 to 3 for the x's and negative 2 to 2 for the y's. 62, and then give you a theta range. You just got to make sure your theta min, theta max is including that. Because if you stopped short, you would have had only half of the picture, and you might not have realized it. But if you keep that range going the whole time, then you could everybody. That's actually a pretty one. They're all like. Alright, kiddos, any other questions on 50? I'm not saying what I'm saying. On section 10.8, which was homework number? I don't know. Something 60s. 60. There. Okay. We're going to the review? I don't mind. Alright, going to the review. Hey, I have the problems right here for the review. I don't think I necessarily have the answers. So if you guys have written them down, so if you guys were just trying to get caught up on all the homework this weekend, slash on Friday when we were working on hard. If you guys notice, wait a minute, where are all the beginning numbers? Oh, we're in chapter 10. We're at the end. Does anyone have any particular ones they've already gotten stuck on? This weekend? I've gotten to it.
We do 93.
Yeah. Oh. 59. I think let's start with the hard ones, that way we can see what's tricky. Because if you start at the beginning, maybe we'll do easy ones that you could have gotten on your own. Right? So for those of you guys just want to pay attention because you're not up this high, hey, just pay attention, you're not up this high. But other people have gotten this high and have gotten stuff. So I would say everyone should be paying attention, not everyone maybe could be writing it down. We'll be saving the notes on right so you can see it there. Or you can set it when it's done. Chris, Nikki?
59.
The only excuse you have for not paying attention is if you already know the one that we're going over, and that's fine. You can wait until you get to one that you don't know, or maybe you know all of them, and so you just keep on working and review, or highlighting formulas to study, etc. Tomorrow, guys, please, you guys should have this down every test. Just want to make sure your table of contents is up to date with 10, 6, 10, 7, 10, 8, easy 100, right? Don't get it pretty easy, not 100. And then have your homework spirals hopefully ready to go through your class. 10, 6, 10, 7, 10, 8 under review. 5 points each out of 20 points. Notes will come straight up to me. I'll be grading homework spirals straight back to Eileen. So you guys can come in and get it all done. Tomorrow is a chapel day. This is a quest. It's shorter than a test. But still, if you can spread out like we normally do, have your calculators under your desk, have your notes turned into the front, homework spirals back on Eileen's desk, and a piece of paper out. I'll get you the test, the quest, ASAP. Okay? And you'll have more time to work on it. Easy. Alright, starting with number 59, the first question that we got to, before that comes up. I want you to sketch it. Indicate the orientation of the curve, eliminate the parameter, adjust the domain if necessary, and verify with the graphing utility. This question would be on the graphing utilities section, so we won't stress too much about graphing it by hand, but eliminating the parameter, that one is going to take a little bit of work. So let's go ahead and remember how to do the funny tricky ones. Number 59 gives us, I'm not going to write all the directions, you guys can see it. Remember, test review, you don't have to write the directions anyway, but you know what the directions are for obvious. X equals 3 cosine, y equals 3 sine. There are multiple ways of doing it, but I think the easiest one for almost everybody is, these are the yucky trig ones. And the yucky trig ones, we go ahead and say, no, we don't want to do the normal solve for theta thing. Instead, we're going to do the get the trig by itself thing. And square. Get the trig by itself, aka I'm dividing both sides by 3. And then square both sides. This might be one to highlight because it's a little special, it's a little different than normal eliminating parameter. But it makes it easy. Once we get the trig by itself, step 1, square both sides, step 2. This is recorded, you can go back and listen to it tonight if you remember what we did in 1. Add both equations. We get x over 3 squared, y over 3 squared. What was the point of squaring and adding? Yeah, cosine squared plus sine squared is? 1. Yeah, the figures are gone. What I have over here, x squared over 9. So y squared over 9. Who is this guy? You can see him if you graphed him in your calculator too. Who is he? He's an ellipse with equal major minor radii, aka. So I'm going a little backwards in the graphing department, but technically if we were to graph, do a square root everybody 1, 2, 3, and everybody 1, 2, 3, horizontal and vertical, major and minor. Everyone goes out to 3. Goes out to 3. Goes out to 3. There is no H or K. So we're going to see. We eliminated the parameter. I guess you get y by itself, but Restrict the domain. I guess the domain is negative 3 to 3, I suppose, but I don't think we actually have to restrict the domain. It's kind of understood. I guess we just get the domain. And graph it your grapher, it should look just that way. And graphing it your grapher is graphing the parametric equations. Remember, kiddos, in your graphing calculator, can you put a theta in par mode? It's a t, but we're just gonna, you're gonna t instead. 3 cosine t, 3 sine t. In polar mode, yeah, there's a theta, but we're not in polar, we're in parametric. We have x equals 1. Alright, our next question was number 83. Once again, these will be saved in the notes. Class notes at the end, where we're working right now. Number 83, ooh, it's another page. Is convert. And I'm going to go ahead and write this just because otherwise you're like, what on? Ooh. Turns back on. Did you last one? Meanwhile, I'm going to keep writing. Let's see if he shows up. Well, I'm thinking about it and getting this. Worst comes to worst, I'll just start writing on the screen, but let me see if it works. So then the directions are for number 83, convert to polar. What is it? X equals? Kiddos, come on, the important formulas for tomorrow. In polar, what is x equal? R cosine. What is y equal? Now, the last thing is really kind of just get r by itself. Right now, I'm going to multiply. There is no distribution. There is no plus or minus. I can just rearrange things and say r times cosine times sine. This is just all one big old multiplication after multiplication after multiplication. R times r is r squared. Usually in polar, we get the r's on their own because it's like getting y by itself. Y equals f of x, r equals f of theta. It's just a thing. So I would probably keep the r's on the left. Have to divide cosine and sine. That is one way of doing it. They could have simplified and said, hey, by the way, you should know over cosine is the same thing as secant, and over sine is the same thing as cosecant. I guess you could have done that. I guess you could plus or minus square root both sides. If they wanted you, like looking at the answers in the back, if they wanted you to get it all nice and correct, remember you have multiple choice, so they're all good. None of them are bad. And they're all polar. They're all good. None of them are bad, and they're all polar. The next question we had was, does anyone want a picture of this? Because once it's gone, it's gone. Yeah. If you want a picture of this, once it's gone, it's gone. Because it's up here, it's not in my next time. Or it's on the video. It is on the video. It is on the video. Next one is number 89 and then 93. Number 89, we're converting the other way. We're converting to rectangular from polar. So we're given the equation. I just lost it. Who has it? R squared. Oh, okay. Okay. You're good, you're good. Kiddos, I would say, once again, yes, you should know your formulas, but then fail-safe is whatever, we have our rectangle plan. Yeah, seriously, I agree. So there is a formula that says r squared is equal to. Good. Sine. There's r sine theta. Triangle. 2 sine of theta. Opposite. Over. Okay. Right? So I can use y over r. Now, who doesn't belong? R. Well, what can I plug in for r? He's not squared. You have options. You can say, well, if r squared is x squared plus y squared, r equals plus or minus square root. And you can plug that in. Or you could say, I want squared. You want squared, just make it. Now, that's kind of messy. I would have probably. Make sure I've got 2 tries in coffee. I probably would have plugged in the square root thing. And this just starts to look really messy. Not impossible, it's just messy. So it's up to you. I'm going to go ahead for sake of simplicity. Most of you wouldn't think of putting a square in. It was right apart. I would just plug in square root. So you're like, okay, hold on. I have r instead of r squared. You want to throw in plus or minus, you can. There's squares all over. It's not a big deal. Yeah. Y multiplying to the other side. This would be to the 1. This would be to the 1/2. You could do all this stuff and make it to the 3/2. But long story short, guys, you converted it. This is one of those, it's not really practical to get y by itself. It's just going to be messy however you simplify it. The back of the book might simplify it more in different ways, but long story short, you got the x's, you got the y's, the r's and thetas are gone. Good for me. If you want a picture of it, grab it now, or look to the YouTube video tonight. Last but not least, number 93. This is like a non-graphing calculator question. Number 93 says, here's an equation. Sketch the graph. Now, they say using symmetry, zeros, max, and other additional points. I say make a table. Anyone else give me a picture? Good, number 93. We're given the equation y is equal to. What was the number?
R equals 4 sine.
Oh, r sine for a polar. Thank you. 4 sine of what? 2 theta. Remember we have thetas on top and r's on bottom? Right away, just by looking at it, if you want for tomorrow's test, remember, there is that shortcut version to symmetries of if there's only a sign, or if there's only a cosine. If there's only a sign, what kind of symmetries are going to have? Is it polar axis cosine? Hold on,
It's, is it pi over
pi over 2.
2?
Polar axis is cosine. There's pi over 2 symmetry. There's pi over 2 symmetry. That could change your table, but let's just go with it like the way that I've been showing. So with sine, if I plug in 0, sine of 0 is easy, so 0 is good. If I plug in, let's see, pi over 6, I'm just kind of going through unit circle values. If I plug in pi over 6, 2 times pi over 6 is pi over 3. Pi over 3, sine of pi over 3 is, square root of 3 over 2. I don't want pi over 6. Actually, I do want pi over 6. You might not totally be tracking with me on this one. But if you plug in pi over 12 times 2, you get pi over 6, which sine is 1/2. That's why we like that one. If I plug in pi over 4, 2 times pi over 4 is pi over 2. Sine of pi over 2 is equal to 1. I like that one. 2 pi over 3, 4 pi over 3, I don't like pi over 3s. If I plug in 5 pi over 12 times 2, that'd be 5 pi over 6. That would be another nice one. I like pi over 6s. If I plug in pi over 2, okay. I don't know. We haven't gotten very far in the unit circle, but hopefully this will kind of help me see what's going on. So if I plug in 0, I'm going to do it pretty quickly just because it's for answering your guys' question. Sine of 0 is equal to 0. Pi over 12 is sine of pi over 6. That's 1/2. 1/2 times 4 is 2. Sine of pi over 4 times 2 is pi over 2. Sine of pi over 2 is 1. Times 4 is 4. 5 pi over 12. 5 pi over 6 is 1/2. 1/2 is 2. And then 2 times pi over 2 is pi. Sine of pi is 0. 0 is. Okay. But what we haven't gotten to, sadly, is where sine is negative. So if you wanted, you could keep going just a little bit to try to get sine to be negative. 7 pi over 6, sine becomes negative, which is why I'm going there. We could go to 3 pi over 4. 3 pi over 4 times is 3 pi over 2. And then maybe pi would be 2 pi. So we could go a little bit further. I missed a pi over 12 in there somewhere, just give us a little more of an idea. And 7 pi over 6, sine is negative 1/2, that'd be negative 2. 3 pi over 4 times 2 is 3 pi over 2, negative 1, that'd be negative 4. We're missing a negative 2 in there somewhere, but then 2 pi sine is 0 again. So we try to put all this together. Some of you are like, how on earth do I graph a pi over 12? Well, you just take a pi over 6 and you cut them in half. So let's see. We have our pi over 4s, just for sake of reference. And we have pi over 4s up here. We have pi over 6, which would be there, and then pi over 12. Oh my goodness. Those are going to be little baby guys. And over here, I have my pi over 4s, pi over 6s, and then my pi over 12s would be about half of that. Then I have my 5 pi over 6. This would be my 1 pi over 12, 2 pi over 12. Let's see what do we got. Tick marks. You need 4, right? So guys, even though these unit circle values are a little bit harder than ones that you've seen, I'm not going to give you, I already said something about I haven't made you guys graph roses by hand, at least not in our class example. So I'm not going to give you a weird multiple angle. And that might be some of your questions. So you're not going to have to worry about pi over 12. You're going to be able to choose from 0, pi over 3, or pi over 6, whatever's easier. Maybe throw in a pi over 2, pi over 4. This one's a little bit harder in that I chose funny angle values, but do you know your unit circle well enough to pick some easy ones? Do you know how to set it up as far as getting angles, nice angles? If you're going to have to do pi over 12 in this. And then do you know that 0, 0, how to graph a shape? Or pi over 12, 2, how to do 2 to 2 and then get a point. For pi over 4, you're going to go out 4 to 4, get a point. 7 pi over 12, no, sorry, 5 pi over 12 is 2 again. And then back to 0 and say, oh hey, I connect in a rotating fashion. And then again, it's a pedal. And then if I was to keep going, going to 7 pi over 12, I actually have a -2. Do you know negative means in the opposite direction too? So you're going to go the opposite direction of whatever angle you're working on. And then 3 pi over 4 is going to be over here, opposite direction. I'm going to go -4. And then go -2 again, and then back. And then maybe some of you realize, wait a minute, sine has pi over 2 symmetry, so whatever's here is going to do what over here? It's going to reflect. So I'm going to have a 2-ish, and I'm going to have a 2-ish, and I'm going to have a, whatever my little guy is, 4-ish, and then I have a pedal here, without even needing to finish my table. Okay, it's a little bit off, you guys have the idea. And then have a 2-ish, and a 2-ish, and then a 4-ish. There we go. Symmetry can help in those sorts of ways. So we can say things like symmetry, pi over 2. Max. What's the max this one was able to go out? 4. Zeros. Let's see, I was getting zeros every pi over 2, I think. 0, pi over 2, pi. So besides the nasty pi over 12, which is because of the nasty 2 on the inside, here's a good picture of the 4-petal rose. Just being for a bummer of the graph. If we take that little 2 theta out, that little 2 out, so we take away the weird pi over 12s. Any other questions on this one? What was this a good example of besides the weird pi over 12s? I ended up using because they were pretty. Graphing by hand. Graphing by hand. I got good questions you guys asked. Sadly, that did get us kind of to the end of class, but we did have a whole extra day where we were able to go over questions of the last few sections. Ugh, that symmetry is awful. If I kept actually graphing, it would be prettier, I think. Anyways. Tomorrow, starting off with the non-graphing calculator. Where are notes going when you come in? Up on the front table, which is to me. Where do homework files go? Back to Eileen. Where's your calculator go? Underneath, because we're starting with the 2 graphing. Let's do 2. No, let's do 1 pair. And then as soon as you finish that non-graphing, well, as soon as you guys spread out, if you want to, you can scope out where you're spreading out, so you guys usually kind of go to the same spots anyway. Once you spread out, people over there, if you want to pull desktop to the side and all that jazz, you can do. When you finish your non-calculator, which you turn in up here, you get your calculator portion, which will be waiting. And then we bust this puppy out. Sound good? Okay. Heads up, this is going to be period 1, period 2, chapel, nutrition, and this. If you guys want to come in a little early from nutrition and start, I don't know. It's up to you guys. But there again, it is a class that will be shorter. It's up to you. Your choice. But I just want to remind you of that really quickly because usually you guys stay in nutrition a little bit, but I'm kind of worried about this. Like 5 minutes early was fine. Alright, cool kids. You brought a book, get it back to me. You didn't borrow a book.